In this tutorial video, we are looking at how to use Pythagoras Theorem to find the length of a missing side of a right angled triangle. Pythagoras Theorem will only work for right angled triangles. We're going to look at two questions. The first one, example 1, will be asking us to find the length of the missing hypotenuse, and in example 2, we'll be asked to find the length of one of the other sides when we're given the hypotenuse length. So looking at example 1 here first of all, so it's asking us to find the length of the hypotenuse. So I'm going to label that x. I'm going to come down and write down my formula for my Pythagoras theorem, which is c squared is equal to a squared plus b squared. Now it doesn't matter, everyone uses slightly different formulae. As long as the c is the hypotenuse length, all should be good. So coming up now to label my picture, as I said, the hypotenuse is always across from the 90 degree, across from the right angle. So that's my x. So I'm going to put a c beside the x, the side I'm actually trying to find. The other two sides are my a and my b. Doesn't matter which you call a and which you call b. So I'm just going to put an a on the 5 and a b on the 6. Coming down and filling in my Pythagoras theorem, I have c squared, so that's my x squared, is equal to my a squared, and my a is 5, so I'm subbing in 5 for a, and I'm subbing in 6 for b, 6 squared. So I have x squared is equal to 5 multiplied by 5, which is 25, plus 6 multiplied by 6, which is 36. So adding the 25 and the 36, that gives us 61. To get the x on its own, we need to get rid of the square, so we need to do the square root of both sides. So that's leaving me with x equals the square root of 61. You can turn that into decimal if you wish, which is giving us 7.81 as a decimal. So that's example 1 done. Coming over to example 2, we're going to tackle it in the same way. We're going to label the side that we're missing. In this one, I'm going to call it y. I'm going to label my picture. Again, remember that the side which is across from the 90 is the hypotenuse. It must be my c. So I'm putting a c on the hypotenuse 3. I'm then writing down my formula, c squared is equal to a squared plus b squared. Again, I can label the other two sides a and b, doesn't matter which is a and which is b. So I'm going to call the y my a and the 2 my b. Coming down and filling in my Pythagoras theorem, that's giving me c, which is 3 squared, is equal to my a, which is y according to my picture, plus my b, which is 2 squared. So on the left hand side, I have 3 squared, which is 9, equals y multiplied by y, which gives us y squared, plus 2 multiplied by 2, which is 4. The aim of the game here is to isolate the y on one side of the equals. So I need to subtract 4 from both sides or move the 4 over the equals. So that's leaving me with 9 subtract 4 is equal to y squared. 9 take away 4 is 5, so y squared is equal to 5. I need to get rid of the square, so I get the square root of both sides. So y is equal to the square root of 5. Again, we can write it as a decimal. The square root of 5 is 2.23 units. So that's the two scenarios that can appear for finding the missing side of a right angled triangle using Pythagoras theorem.